Hello everyone, my name is ENGR, and this is the Oregon Institute of Technology Engineering 267 Engineering Programming Extra Credit Problem Number 1. The problem is stated as a movie theater line has 200 people, the movie ticket costs $5 and people pay with $5 or $10 bills with equal probability. Design a simulation study to calculate how many $5 bills must the cashier have initially in order to have enough change at all times with a probability of 0.95. As a hint, use the RAND function to simulate the method of payment. Okay, in the code, we start with just a little cleanup. We set the number of people to 200. We've run 10,000 simulations. Our probability is equal, we'll do the RAND function, number of simulations and number of people, and the initial $5 bills that we run through are in a vector 1 to 50. First we have a for loop that sets our initial $5 bills, and we say that the no change needed is equal to 0 initially. And a for loop within here to cycle through the simulations where we count, and each change is equal to 0. We cycle through the people in each simulation with another for loop with if else, and end statements for the probability, and another if statement, of course, that we must give change for a $10 bill, and I'm actually just going to fix this little typo here. Okay. And which does an increment, okay. And then out of that for loop, if need change is equal to 0, no change needed is equal to no change needed plus 1, of course, increment it. Need change total is equal to need change, okay, so we're accumulating that percent success equals no change needed over k, which came from the loop above over here. And we output the data, from the simulation run, okay, and after that for loop is exited, we output data from initial $5 bill count. Okay. And after all of the loops have run, we have a score, okay, which we find the output data of $5 bills, where it's greater than or greater or equal to 95% there. Number of $5 bills and probability percent, okay, and then we output the data, okay, and then we just have one more variable we call output table, puts everything in a nicely formatted table, and finally we print a summary. So we'll go ahead and run this. It does take a second just because there are 10,000 runs occurring, okay, and it outputs us this nicely formatted table, okay, where we have our column headers in bold, okay, and we see that the probability increases until we hit here, okay, with 28 initial $5 bills needed, okay, and with the summary, of course, that matches up, that with 28 $5 bills, the box office has 95.61% probability of having enough change in $5 bills. Doing subsequent runs may give a slightly different number. 27, I think I've seen it down to 26. And we let this run. Okay. Same sort of table outputs, and we see that once we hit 27, we are at our 0.95 probability, 95%. Okay. And so this concludes my video. Thank you for watching.